Have you done this?
No.
No? All right, so maybe we'll talk about it next time.
Wait.
I mean, you have to do this by yourself first.
Straight lines, not curves, or like curves overlapping, because a function can only have one. I think we've done this.
Yeah, you can. No, I mean, have you done the homework?
Oh, the homework. Yeah, I've done the homework.
Okay.
I'm gonna put it on Google Classroom.
Yeah. Okay. You can always check if this is a function by using the vertical check, right? That's to make a vertical line to see how many intersections do you have, right? So for functions, for any x, there must be only one corresponding y, right? So apparently this one is a function, right?
Yeah.
And the second one
Yeah.
is also a function. Because you can check for any given x, there is only one y that is corresponding to x. So y is a function of x, right? Okay, for this one, again, use the vertical check. For any given x, there's only one value of y that corresponds to x. So again, y is a function of x, right? How about this one?
No.
If you check here, for given x, there are two values corresponds to the same x. So y is not a function of x, right? But everything is relative. So if this is the axis of y, this is the axis of y, x. So consider this statement. X is a function of y. Is that true or not?
No.
X is a function of y. That means for any given y,
Oh, yeah, yeah.
there must be only one value of x that corresponds to the y, right? So if I give you a statement like x is a function of y, this graph should be correct, right? But y is not a function of x according to this diagram, right? So remember, everything is relative. You need to consider which one is dependent variable and which one is independent variable, okay? All right, for the second question, state the domain range of each relation below. Each relation, so not necessarily a function. And is each relation a function or not? Okay, so for the first one, so suppose this is a independent variable, this is dependent variable. Then the domain is just the collection of all the independent variables, right? That's 1, 4, 3, 5, 11. This is our domain, right? All possible values of the independent variable. And the range is the collection of all possible image of the independent variable, right? Which are 5, 11, 9, 1, 4, right? Okay, for question B, again, for the domain, it's a collection of all possible values of the independent variable, but you cannot contain the same element for more than once. So that's 3 to 1, right? 3 to 1, 2, 3. You don't have to write 2, 3 here because we have already had 2, 3 here. So when you write a set does not contain repeating elements, okay? Each of the elements are different. And the range are the collection of all possible values of the image, which are 2, 1, 0, -1, -2, okay? So is the first relation a function? You must use the definition of a function to check, right? For any given element in the domain, there is only one element in the range that corresponds to the given variable. Apparently, this is yes. How about the second one? This is not a function because, for example, if I give you a 3, there are two images of 3, right? Which is 2 and -2. That means for a given element in the domain, there are two elements in the range that corresponds to this element. So this is not a function. Okay. Next one, determine the domain and range of each relation below. Okay, for the first one, what is the domain? There should be no restriction for x, right? So the domain is just a real number set. So how about the range? Range is all possible values of the image of x, right? But how do you find the range?
-4.
Yes. This part is always greater than or equal to 0, right? And this whole part is any real number that is greater than or equal to -4. So the range is y belongs to real number set and y is greater than or equal to -4. Or sometimes you can also write in the interval form, which is -4 inclusive to positive infinity. They are the same thing, okay? You can choose either way. Okay, how about the second one? Can you recognize what it is? The graph of this function.
Triangle.
We have learned this, right? It's not a triangle, it's a circle. Remember, a circle, equation of a circle is x minus a squared plus y minus b squared equals r squared, right? A, B is a center and R is a radius, right? So it's actually a circle. So what is the center of the circle? 0, 0. X minus 0 squared, y minus 0 squared. So it's 0, 0. And the radius is 3, right? Radius is 3. So can you tell from the diagram what is the domain? Domain is from here to here, right?
-3 to 3.
-3 to 3. And range?
-3 to 3.
From here to here, also -3 to 3. That tells us sometimes you can use the graph of this function to find its domain and range. Of course, you can also do that on the first function. This is actually a quadratic function, and this is called a vertex form, right? You can also check the domain and range using this graph. Okay, third one. What is the domain? Any restrictions on x? Or there are, when you have a square root symbol here, there should be some constraint, right? So how can we find the domain? Domain is any value of x and makes this expression greater than or equal to 0, right? Which is equivalent to x greater than or equal to -1/2, right? Or sometimes you can write it like this, from -1/2 to positive infinity, inclusive. Okay, how about the range? Okay, actually, the number under the square root symbol can be any non-negative number, right? The square root of any non-negative number can also be any non-negative number, right? So the range is y belongs to real number set and y is greater than or equal to 0, right? Or you can also write it like 0 inclusive to positive infinity. Okay. And next one. Okay, so you have 90 meters in total, and the width must be x, and the 3 rectangles here are identical. That means this side must also be 3x, right? And This side is x, this side is x. So what is the length here? 90 meters in total, right? Minus 1, 2, 3, 4, 4x. And this number over 2, because you have two sides here, right? It's the length of this side. Therefore, okay. Express the area function for the 3 pens in terms of x. So what is a total area? Total area is length times width, right? Length is 90 minus 4x over 2, then times width, which is x. And this is the expression of the area, which is 45 minus 2x times x. And you can use, okay, let A stand for area. That's negative 2x squared plus 45x. That's a quadratic function, right? Okay. Next is to find determine the domain and range for the area function. Okay, so this is a real world problem, and you should consider not only the expression itself, but also the limitations from the real world, right? Okay, so what are the limitations? There are two limitations, right? X is width, therefore x must be greater than 0, right? It's a distance, so it must be a positive number. Second of all, the length, which is this expression, must also be positive, right? Therefore, the limitations for x must be the combination of these two expressions, which is equivalent to, first, x must be greater than 0. Second, 4x must be less than 90, which means x must be smaller than 22.5, right?
Mm-hmm.
Therefore, the domain of this function is 0 to 22.5 exclusive, right? Okay, so how do you find the range? Note here, your function is this. A equals negative 2x squared plus 45x, right? This is your function. How do you find its range? Note here, this is a quadratic function, right? You can use its diagram, its graph to find its range. First of all, opens down, right? Leading coefficient is negative, so opens down. Whether it has any zeros, we don't know yet, but according to the expression here, there should be two zeros, right? Can you find two zeros? One of them is
Okay.
zeros means if I let A be 0, what are the x's? One of them is 0, right?
Mm,
When x is 0, A is 0. How about the other one? The other one is
45.
this number be 0, right? So that's 45 over 2, right? Okay, so our domain is from 0 to 22.5, which is 45 over 2. So x ranges from here to here. So can you tell what's the range? The range is from
Here
this
to
side
here.
to the point here, right?
Mm.
So we must find the y-coordinate of the point here. Oh, this point is actually the vertex.
To the half of that.
Yes. But it's nothing to do with this point. You have to find the y-coordinate of this point.
Oh, why?
Yeah, because the range is all about y, right? So in this case, it's a. The smallest possible value of a apparently is 0. largest possible is the value here. So how to find this value? Two ways, right? You can use the coordinates of the vertex. We have already learned that if you have a quadratic function like this, what is the y coordinate of the vertex?
0.
No, not 0, it's 4a denominator.
Oh.
4ac minus b squared, right?
Mhm.
So what is 4a? -8, right?
Mhm.
4ac 0, right? Because c is 0.
Yeah.
Minus b squared,
45 squared.
45 squared, which is 45 squared over 8. You should be able to find this number. Okay, let's calculate. 45 squared over 8.
And 25 over 8.
Yeah. Okay, therefore the range is from 0 to this number, right? You see that?
Mhm.
Inclusive. Okay, and the second way to find the y coordinate of this number is to put the x here into this expression, right? So what is the number here for x? This is the midpoint of this 2 point, right? So that's 45 over 4. You see that? So to find the y coordinate of this point, just put a 45 over 4, which is -2 times 45 over 4 square plus 45 times 45 over 4. You can also find the y coordinate of this point. You understand? Okay, so that's the second way to find this y coordinate. Okay, any questions?
No.
Okay, let's see next one. For each function below, determine f4 and f -2 over 3. This is simple, right? You can just put f4 and f -3 over 2 over 3 into each of the functions, right? Okay, I'll do the first one for you. f4 is 2 over 5 times 4 plus 11, right? It's 8 over 5 plus 55 over 5, which is 63 over 5. And f -2 over 3 is 2 over 5 times -2 over 3 plus 11, which is -4 over 15 plus 11 times 15 over 15, which is 165 minus 4 over 15, which is 161 over 15, right? So just put this number in the expression and you will find its image, right? Image of 4 and image of -3 over 2. So I won't do it, do the rest of the question for you. Save some time. And next one, write each function below in mapping notation. Okay, so remember you can write the function in the mapping notation, right? So mapping notation means fx equals -x plus 4. So that means f is a function, right? This function maps x to -x plus 4, right? This is called a mapping notation. Understand? This is another way of writing a function. Okay, for b, again, g is a function name. So g is a function. It maps any x to x squared plus 5x minus 3, right? Okay, this is quite simple. Okay, next one. The value V in dollars of an N-year-old car is given by this formula. How much was this car worth when it was first purchased? So this is a word problem. So note here, N stands for the age of the car, right? So when this car is firstly purchased, it's a 0-year-old, right? So for A, we just let N be 0 and then find the image of 0, right? So what is V0? We can simply put 0 there. That's 0 plus 1 plus 1,000, which is 24,000, right? Okay, next, determine the value of the car after 10 years. Okay, after 10 years, that means V10, right? You can just let N be 10 and find the image of 10. So 10 plus 1 plus 1,000. And of course, you can find this number by using a calculator, okay? I'm not gonna calculate this for you. And again, I'll leave the other one for you as well. How long would it take the car to depreciate to a value of 2,000? So what does this mean? This means you want to find n, right? Such that Vn equals 2,000, right? Okay, what is Vn? Vn is 23,000 over n plus 1 plus 1,000. Okay, so this means 23,000 over n plus 1 equals 1,000. Therefore, we can find n plus 1 must be 23, right? And n must be 22. Okay. So what does this mean, n equals 22?
Here.
Yeah, it means the car is 22 years old, right? That's the final solution. Okay, how many? Okay, 3 questions remaining. 8 given fx equals fx plus 1, fx plus 1 plus 3, and f2 equals 5. Have you done this? Okay, so if you don't know how to do this, sometimes you can just try, right? Try and error. You can use that always. So this means f2 equals f3 plus 2, right? And as you can see, f3 equals f4 plus 3, right? And we can continue right like this. Then we can have f6 equals f7 plus 8, plus 3, and then f8 equals f7 equals f8 plus 3. Why should I write like this? Because we want f8, right? We want this one. So according to all of these, you can add the left and right, right? Because each of them is an equality equation. If we add all the left, we get f2 plus f3 plus dot 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 plus f7 equals the sum of expressions on the left, right. That's f3 plus f4 plus dot 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 plus until f8 plus how many 3's are there? We have several 3's, right? How many of them? 2, 3, 4, 5, 6, 7.
All right, but there's only 2 to 7. So there's only 5.
2, 3, 4, 5, 6, 7. Should be 6, right?
No, 6.
You should have 6 equations, right? Okay, 6 equations. Let me put a note here. You have 6 equations, right? So that's 6 3's. Okay, so here we can cancel f3, right? Because you have that on both of the equations. And cancel f4 until you cancel f7 with this one, right? So what's left is only f2 on the left side equals f8 on the right side plus 18, right? And we also know what is f2. f2 is 5, right? So put f2 equals 5 in. Then we can solve f8. So f8 equals -13, right? Okay. Next one. Okay, you want to find f2 plus g3, right? So the intuitive way to do this is, if you know the expression of fx and expression of gx, then we can just put 2 into that expression, right? So given the two equations like this, is it possible to find fx and gx? So note here, you can consider fx is an unknown variable. Then we have two unknown variables, which are fx and gx. And then two equations. It's possible to solve them, right? So let's call this number 1 and this number 2. We can use number 1 times 2. This gives us 2 times fx plus 4 times gx equals 24x squared plus 12x plus 16, right? Then use 3 minus 2 to eliminate one of the variables. So if you use 3 minus 2, left side is gx, right? Right side is 6x squared plus 6x plus
Hmm. Oh. No.
this should be 6.
6x.
6. This should be no x. 6x squared plus 3, right? Am I correct?
Yeah. -6. Oh, no. Yeah, that's 3.
Yes. Also, we can use first equation times 3, which means 3fx plus 6gx equals 36x squared plus 9x plus 24, right? Let me call it 4. Then we can use number 2 times 2. Which will give us 4fx plus 6gx. So why we should do this? That means we can cancel the gx, right? To find its least common multiple, right? Least common multiple of 2 and 3 is 6. Okay, so right side is 36x squared plus 12x plus 26. Let's call this 5. Then we can use 5 minus 4 gives us, left side is just fx, right? Right side is 3x plus 2, right? Okay, so we have gx is here, fx is here. So it's not difficult to find f2 plus g3, right? Just put the numbers in and it's done. Okay, last one. Fx is a function which is square root of x. Gx is another function, square root of x squared minus x minus 6. A, find the domain of fx. Domain of fx. Okay. Any restrictions on x?
No
Apparently,
negatives.
x belongs to real number set and x greater than or equal to 0, right? Or sometimes you can write it like this. This is quicker. From 0 to positive infinity. 0 is inclusive. And the second one, domain of the second. Domain of the second function is, again, the expression under a square root must be greater than or equal to 0, right? We want to find the solution of this inequality. So note here, this is a quadratic inequality, right? So how do we solve that? You still remember?
Yeah.
You can use a diagram, use the graph of this function to find the solution, right?
Mm-hmm.
Okay, so
And
can
then
you,
also just solve.
yeah, solve?
Yeah, like
Yes, you have to find zeros. So first of all, it's opening up, right? So you want to determine whether there are intersections between this function and the x-axis. So let's try to solve it. Actually, this is quite simple. Can you factor the left side?
Yeah.
The 1, because the leading coefficient is 1,
Yeah,
right?
then 3, 2.
-6 is -3, 2. And by cross, you get -3 plus 2, which is -1, which is -1 here. Okay, so sorry, too early to cross this out. So first is x minus 3. Second factor is x plus 2. Okay, so this means x -3 times x plus 2 greater than or equal to 0, right?
So it's 3 and -2.
Yeah, are there any zeros? Zeros is
-2.
x equals 3 or x equals -2, right? So this corresponds to the two zeros here, -2 and 3, and it's opening up, right? So this is a sketch of the quadratic function. So this is why we have put a lot of time to study the graph of the quadratic function. Okay, we want to find any interval that makes this function greater than or equal to 0. Can you find it on the graph? It should be this branch and this branch, right? Therefore, the solutions are x is either smaller than or equal to 0, or x is greater than or equal to 3, right? Sorry about that. Let's make a phone call. Okay, and next one, Sx is a new function. What is domain? Okay, note here, the domain of the first function is here, right? Wait a minute. Hello, 怎么着？哦，行，哦，行，我在等你。好的。Okay, the domain of the new function should be the combination of these two, right? So the new domain is, first of all, x must be greater than or equal to 0, which is the domain of fx, right? Second of all, consider the domain of gx, right? Domain of gx is x is less than -2 or x is greater than or equal to 3, right? Remember, x must make both fx and gx meaningful. So it must be a combination of the two domains, right? Okay, then let's consider there are 1, 2, 3, 3 numbers, which are -2, 0, and 3. First, x must be greater than or equal to 0, right? Second, x can be less than or equal to 0, or x can also be greater than or equal to 3. So what are the common area?
Greater than or equal to
Only
2.
here, right? You see that?
Yeah.
Therefore, this is equivalent to x is just greater than or equal to 3. So this is the domain of Sx, right? Okay, last one, dx equals fx over gx. So what are the domain? First of all, x must be greater than or equal to 0. That makes fx meaningful, right? Second of all, x must be smaller than -2, or x greater than or equal to 3. That makes gx meaningful, right? Do not forget gx is denominator, therefore gx cannot be 0, right? Okay, so next is to simplify this expression. So the common area of the first two we have already solved, which means x must be greater than or equal to 3, right? Second, gx cannot be 0. Okay, gx cannot be 0 means, what is gx? Gx is this one, right? right? And we have already factored this expression. That means x is greater than or equal to 3, and x minus 3 times x plus 2 cannot be 0, right? That means x cannot be 3, and x cannot be negative 2, right? So simplify to this. Okay, so what are the final solution? If x is greater than or equal to 3, x apparently cannot be negative 2, right? So this expression actually implies x cannot be negative 2, right? But does not imply this one, right? So we need to remove the point of x being 3.
Why is -3?
Sorry, that should be 3, right? So the final solution is x must be greater than 3. Okay. All right, these are the basic concept of a function. Okay. So next time we'll consider the concept of inverse of a function. Have you studied that in school? The inverse of a function means if I give you fx, can you find the inverse of fx? Okay, so next time we'll talk about this, okay? I'll upload my notes onto Google Classroom. If you want to refer to that, you can always check Google Classroom. Okay, so see you next week.